is congruent to A prime, B prime, C prime. Okay. Dilation. I don't think we've done any like dilations yet. Anybody had their eyes dilated? Eye exam? What happens when they dilate your eyes? And then you look like you're from Mars or someplace. It's a little obnoxious. Okay. So you've got a dilation where they dilate your pupil and make it really big so they can see inside there. But a dilation is a transformation that makes an object larger, smaller, or it might keep it the same size. As the original from a center point. So your eyes dilate from the center of your pupil out. Okay, we're going to look at a dilation with the center at the origin and a scale factor 2. That means everything's going to get 2 times bigger. Okay, to get this one to fit, put the y-axis to the left and put the x-axis down off of center a little bit, so it's there. Okay, we're going to plot triangle ABC, and then I'll show you how to do the dilation. It's easier to do the points and then go back and graph. So A is at -1. Okay, to dilate something with a scale factor of 2 around the origin, I'll give you the rule right off the bat. All you're going to do is take the x and y values and multiply them by 2. Because we've got that scale factor of 2. So where is A going to land when you dilate it by a scale factor of 2? -2, -2. So -2, -2. Where's B going to land? 2, 4. And then C will land at 4, -2. All the dimensions on that triangle got 2 times bigger. Every side length got twice as big as it was. So using that rule, where will E land? That's 5.1, so 10.2 and -16. And I forgot the last little box here, because those only work if the scale factor is 2. Well, can I multiply by a different number? I might want to make it 3 times bigger or 10 times bigger. Maybe I wanted to make it half as big as it was. I could multiply by a half. Or I could multiply by a quarter or 2/3. If I want to make it smaller, I multiply by that fraction. So, the rule is, whatever scale factor you want, you just multiply that by both the x and the y. So it's k times x and k times y, where k is your scale factor. Like I said, it could be a fraction under 1 to make it smaller. If it's over 1, it makes it bigger. What happens if it's equal to 1? It stays exactly the same, right in the same position, stays the same size. So most often, it is not congruent to the original one. Only if k equals 1 is it the same. This one does, they don't stay congruent here. Okay, rotations. That's where the index cards come into play. What's a rotation? You're going to turn it. Rotation is a turn. Okay, we're going to rotate 90 degrees clockwise around the origin. Okay, some people caught on with the card really well, some people did not. You're never going to use the card again after we discover the shortcut, so if you can't follow the index card, it's okay. Center your axes, both of them. Plot A, B, and C. Don't worry about D. It's a little confusing if you stick D in there right now. So just A, B, and C. Again, it's a little bit confusing with the card. They showed me a way I think is better than my way of just estimating. First someone figured out a little bit better way than I had, so we'll use their way. Are you ready? Okay, we're going to rotate point A. We want to go 90 degrees clockwise. So I want to pick up point A, rotate it 90 degrees, and drop it back down. That's my goal. Well, what's nice about an index card is we've got a nice 90-degree corner here. So if you put one of the corners at the origin, and you mark the distance to A, I know you might have a lot of marks on there, but put a little A by it. Make it bigger if you need to. So far, so good? And what you want to do is be able to see through the other side and mark that same spot. So you can pick it up. See, I can see my A there. Put a little A by it, so it's on both sides of the card. I just kind of look through it, you can kind of see right through the card. Are you good there? Do you have the A marked on both sides of that same spot? Okay, so what we want to have happen is we want this A to rotate to the other side of the card. Well, all you're going to do now is pick up this card and spin it. Keep that same corner at the origin. Line up the edge. It should have no marks on it. Well, maybe you got marks in the last class, but line this up with A, and now you know with the same distance away you've marked it. So this should be the mark that was on the back side of the card. It's going to land right there.
So you can move that card wherever you want.
No, you got to have to keep the point at the origin though, because we're rotating around the origin. We're spinning at 90 degrees.
That gets in the card 180 degrees.
See it?
Put it wherever you want.
How'd you flip it exactly?
I had it right here.
Yeah.
See how the lines were up? The lines on my card were up?
No. I messed that up.
Well, then yours is plain.
Yeah.
Okay, so set it on there.
Awkward.
I don't care. Set it on there. I don't care how you do it. You got the plain side up or the line side up?
Plain.
Okay. Now flip it over so that your lines are up. Put that same corner at the origin and line up that other edge. This mark should be showing you a spot.
Yeah, I know.
Anyways, where did we land? Like I said, if you don't get the card thing, it's okay. Where is this at? 4, -2. Okay, let's do the same thing with B. Take a corner, it doesn't matter which corner. Mark the distance from the origin to B. Flip it over and mark it on the other side. You gotta kind of see through it. So I've got the plain side up this time. Now I'm going to flip it over. Keep that same corner at the origin. Line it up with B. Line this back up with B. And then where it hits, looks like it wants to be right there. And where is it? 3, 2. Again, if you can't do the cards, be looking at the point for a pattern. We're doing one more and then we want the pattern. What can I do with the original point to get the new point? So let's move C 90 degrees clockwise. So I gotta go. You see the pattern? Good. The pattern is what's important. So there's C. Mark it on the other side.
I get the pattern.
You got the pattern?
Yeah.
Let's see, where did that bugger land? -5, -1. Nice little boat edge there. Okay, let's do the pattern before we do D. Jake, you said you got the pattern?
Yeah.
What do you do to the original X and Y to get the new X and Y?
Just flip it.
So just switch them, switch the order?
Yeah, and then make it negative and positive.
Make what negative if it's positive?
The Y.
The Y. So, do you agree with Jake's pattern?
Yes.
He said you're going to flip the order, so the 4 and 2 are going to switch places, and then you're going to take the opposite of what was here. So what was the Y is now the X. Do you agree with that? So I put the Y first, and then how do I figure out this new second value? It's the opposite of whatever X is, and we write opposite of X with negative X. Does that pattern make sense? So, where would D land then if I was to put my card on there and rotate it? -4 would be the X value. +1 would be the Y value. And then how about E?
Negative 99.
-99 would be the X value.
Negative 22.
-22 would be the Y value. So it's all about understanding the pattern. How were you with that, Sophie? This part's okay? This is what you need, not the card business. The card business is just so we can discover this. You won't be using cards after we get the notes done. Okay, let's go 90 degrees counterclockwise about the origin. Let's see, we want everything centered here. So 2, 4. Oh, 5. And if you've already got your A, B, and C on here, we just got to lay the card on there so that we're going counterclockwise. So you want the card to be to the left of your point. So if I wanted to rotate A, I would line it up like this. Counterclockwise, I want to